Hello everyone, welcome back to Dragonfly Engineering. So this week we've got a special episode where I actually meet up with Kwith Rucker at his shop in Tifton, Georgia, at the end of his first Arnfest South Festival. And in that visit I delivered the wrist pin, which is a part that he requested that I help machine for his Stoker Steam Engine. So this is the wrist pin. And I will show you a little clip where I give the pin to Kwith and we talk about how this wrist pin is used in the Stoker Steam Engine. And then the second half of this episode will be footage of me machining this wrist pin on the CNC lathe. So, hope you guys enjoy. It was literally during his open house session at his shop on Sunday after Arnfest. So there was a bit echoey and there was some kids and other people running around the shop, but we decided to just do a quick impromptu discussion about the wrist pin.
Okay. All right. So, action. Action.
All right, we good?
Yep.
All right. Hi everyone. Welcome back to Dragonfly Engineering. So I'm on a special trip here with Kwith Rucker's shop. We just finished the Arnfest South. The very first one, right?
Very first one in the South, yes.
Nice. Yeah, and so I'm sure you've all seen Kwith Rucker's show, Vintage Machinery, on YouTube. And I came here to visit Kwith, and we're going to talk about the Stoker Steam Engine.
Yeah.
And a few of the parts that I helped make for Keith's project here.
Absolutely.
Using the CNC lathe. So, one of the parts is the piston rod, which was made a couple of years ago. I met you at Good of the Land Fest.
Good of the Land Fest out in Texas, yep.
And Kwith was asking YouTubers if they were interested in helping build some of the parts. And I want to say, like Brian Block and Blondie Hacks.
Yep, Blondie Hacks
and
made some
Dragonfly
parts.
Engineering.
You did some. Brian Block helped out on some stuff, and I think that may be it.
Anyway,
yeah.
So it was a little bit ago, but yeah. So at that time, I helped Kwith and made a couple of these piston rods for him, including machining the castle nut, which, in retrospect, I probably should have just bought a nut and just machined in the castellation on it. But yeah, so this we made two of these for him, and then recently for the Arnfest South. I asked Kwith, or maybe you asked me.
I think I asked you, yeah.
But I guess the family part to the piston rod is the wrist pin. So Kwith asked me to use the CNC lathe to cut these as well. And I made a few of these, and you're going to actually case harden these?
That's right. So the original parts, right? Yeah, the original parts, I got the blueprints on this. This is made out of low carbon steel, which is very tough, very resilient, but on the surfaces up here where the bearings are running, they need to be hardened. So the blueprints actually call for this to be case hardened. So we're going to use the heat treat oven, and actually we'll basically put a carbon powder on this, and that will, when it's heated up, will absorb into the metal and just on the very surface, and that then once it has the carbon in it, it can be hardened. Mm-hmm. And of course in the heat treat process we'll do a quench and everything else to harden it, and then it has to go and be ground, and I've got a cylindrical grinder that has never actually been used on the channel. So
yeah, we were looking at that.
So I'm gonna probably have to do a little bit of work to get it going and get it doing what we need to do. And of course, my first job on it, we're gonna be doing tapers, so just jump right in there,
Yeah.
But anyway, we're gonna have to grind this down to the proper size and get it all on there. So anyway, this helped me out. I could have done this on the manual lathe, but man, this is a part that screams CNC, and you volunteered to do it or agreed to do it, so I was glad to let you do it. So.
And I was glad to do it.
Yeah,
because I actually don't use it's a ProtoTrack CNC lathe, which is sort of an entry-level CNC lathe. You can use it as a manual lathe or as CNC, and but the nice thing about CNC is it's infinitely accurate on these tapers, where if you're looking at a needle on a dial, you're not sure if you're down to the level that basically the locking taper, this knuckle, needs to see.
Yeah.
Should we pull up one of these?
Yeah, we can come in. You come in really close and take a look at this. So this is one of the original wrist pins that were in here, and ironically, it's broken. And I did not do that. I think this happened when they were trying to disassemble this, and they had to put so much torque on it, it snapped off.
Yeah, it looks like it's been broken for a while.
Yeah, it's been broken for a while. But basically, the wrist pin has tapers on both ends, and then the center part is where the bearing actually runs on for the connecting rod. But the tapers lock it into the crosshead, so this actually fits up in here kind of like this. There's a pin here to keep it from spinning on the end, and it all just kind of locks in there together. There's a nut on the end, a castle nut on the end, and the castle nut has a pin that goes through it so that it won't unwind itself or whatever, and then the connecting rod runs on this bearing surface here. So,
oh, I can see a pit in the old one. Is that
yeah,
where the boiler was?
That's where the oil holes were, and this thing had water get down in it, and where the water got in there, it rusted a little pit in there.
Oh, man.
Where the bearing was so tight, there wasn't room for water to get in there, and probably had a little oil and grease or whatever in there as well, so it didn't rust.
Except for the one spot
right there where the oil hole was, and I saw that in a lot of the bearings, a lot of the parts on here. You know,
so
you see
that's the rust etching.
rust etching from where the oil hole was. Yeah, kind of interesting. But these are the new ones, and right now they're oversized because we're gonna have to grind it down. But these will fit up in here, and he left me a little piece on the end to chuck on. That will be removed before we put them all together, but that will give me some work holding to make life a little bit easier. But you can see it doesn't go all the way in. We got to grind it out, and this center surface has got to be ground out as well. So that will be coming up, and some stuff we're going to be doing soon. And yeah, I'm going to probably do this on the cylindrical grinder, although I may try to find someone with a CNC grinder and get them to do it. It's going to be challenging because this is a constant taper from one end to the other, but this area here is not. It's a constant diameter, but this end is larger than this here, so you can't do a solid taper on there. And
yeah, they made it easy on the knuckle with just a solid taper, but
this is going to really be, I'm not going to say you can't do it on a manual cylindrical grinder, but again, it's a part that kind of screams CNC. So I may see if I can find someone that's got a CNC grinder and just let them grind it, but we'll case harden them here. So I haven't.
Well, you do have the practice piece.
Yes. Yeah, we made an extra piece because we figured we would need to kind of figure it all out. So
yeah,
it's kind enough to do that for me.
I was wondering if you were gonna find the angle by just skim grinding, and then when you feel that you're on it, then you actually do the grind. Yeah,
well, I'll probably, if I use my machine, what I'll probably do is we'll set it up. I've actually got a taper micrometer, so I can actually measure that taper very accurately.
Oh, okay.
And make adjustments from that. So I know what the taper is, and with you having done it on CNC, it should be dead nuts on. So
yeah,
we'll probably do that. And then the other thing I will probably do is before we actually run the parts is I will run an indicator over these parts and on the machine, and I can put this in here and run an indicator on there and just make sure the indicator's set up right.
Because this should be an accurate impression of what you're seeing on this part.
Yeah.
So that's a good point.
So
you've got a template there too.
We can dial it in with the taper micrometer, and then we can also kind of prove it out with an indicator. So I think we'll be fine. So
okay.
Yeah.
I'd also like to thank Keith for hosting the Arnfest South. It was a great event. And also the open house in his shop. I've got some footage of checking out his very envious shop here. So thank you, Keith.
Thank you.
And thank you for the opportunity to help with the Stoker Steam Engine too.
Yeah, this has been a fun project, and there's been a lot to it. There's still a lot to do to it, but we're making progress on it.
Great. All right, well, thank you for watching Dragonfly Engineering, and that'll be a cut.
All right, good deal.
All right, so that was the quick kind of in-shop impromptu interview / discussion about the wrist pen. So now we're gonna go and show how I machined this wrist pen. So I bought some of this 1018 steel that Kwith Rucker specifically requested so he could case harden it. I assume he's gonna case harden it with carbon to get a nice hard shell that's resistive to wear in the Stoker Steam Engine, which this is a wrist pin, or it's going to be the wrist pin. And so I think this is the connection between the piston rod that I made for him a couple years ago and the knuckle, and then this is going to be the pivot pin for the rotational part to go into the linear part of the steam engine that pushes in and out. So this is the kind of the pivot pin for that. Okay, so but I had to get 2.5 inch from the local steel supply manufacturer, but the bore in my chuck here is 2 3/8 inch. So the first op, or the 0 op that I'm going to do, is basically just turn this a lot of this meat off, because our final dimension is slightly over 2 1/4 inches. So I'm going to turn this down so I can get the bulk of this billet into the bore of this chuck, and that way I don't have so much stick out when we machine the back reference post and the dome-shaped profile of this part. So let's load it up, and I'll just kind of hog off approximately 3/16 of an inch or so. I like to spin stock as I'm slowly tightening to try to get it reasonably square. And then we can put the indicator on the back on the table. And I'll just stick it right on there. This is just a real rough kind of dialing in of our stock, just so when I turn this on, it's not going to be vibrating the lathe too much. Adjust the height. Again, this is just roughing it in. Let's see what we got. Probably come in a little more. All right, so I'm going to manually spin this. You can see we get a 20 thousandths or so. I'll see which direction I need to bump. So, need to bump this down. There we go. And now we're at 5 thousandths or so. Maybe I'll give it a little more. I'm pulling down with my hand to help dampen so we don't get kind of ringing and spring back. It kind of helps with a quasi dead blow effect. Here we got a few thousandths, so that should be good enough. Again, this is just so I can safely turn this part sticking out in the chuck like this to just hog off material. There we go. And we'll release the mag base and pull this off. All right, we got a RPM of 630. And it's actually set to surface feet per minute. I think it's like 500 surface feet per minute. And so as we get closer to the center of the stock, the RPM goes up. And then back down when we get further away. Let me reposition the camera. All right, here we go. So we're gonna cut down to about 2.35 or so. I'm gonna get a little coolant on here. Actually, I'll probably be spraying the camera. Let me readjust. All right, get a little coolant. And we'll just turn this down so it fits. Take a little bit more off. 2.35 should be good. I'm just bringing the CNC on here. The CNC lathe, but you can use it for the manual lathe. There's a logo now. We'll fix the CNC pretty soon. I'm using the 0.5 insert. Oh, the diamond shape one. And a little bit of it. All right. So we'll back this off. Pull our little bird's nest off of there. And we're now going to flip this stock around. Oh, it's kind of a rough cut, but it doesn't matter. so we have less stick out of our stock in our chuck. I'm gonna put this into the bore. And then we'll grab onto the back. We can recheck, see how reasonable this 3-jaw device is, or chuck. I don't have a 4-jaw chuck. It's one of the things I want to get eventually. But the scheme that we're going to follow, I don't think a 4-jaw is needed, because we're basically going to machine in a post for Kwith Rucker to use. I'm going to flip this over, and then we're going to use the post as our reference in this chuck to spin, and then basically have a drill center drilled on the end of our part. I'll show you here. So I'm going to get up in here onto the previously turned area that we just did and see how we're looking. And we're actually within a thousandths. It's just hopping over the coarse feed. So that's good. Yeah, check that out. It's not bad. Okay. So I do have the 0 already set because this is the third part. Keith wanted one extra part so he could practice on his grinding system, because he's going to grind this in. So we're actually making the bearing surfaces larger because he's got to heat treat it and then he's going to grind it. So I'm going to machine in a 1-inch post by 1 1/4 deep, 1-inch diameter, and then just the dome end of this part, and which we'll take a look at on the CAD. All right, so I'm going to face the end of this stock off at position of 0 on the DRO. We'll do a couple passes. Again, the RPM goes up as we go to the center of the part due to the constant surface speed. And I'm just hand cranking this. All right, I'm going to back off. All right, so now we're going to run our program that will cut in the boss and the dome back profile. This is the third part, so I've already run this a couple times, so this may just be real. All right, run, start, and then hit ready to begin, press go. Turn on the spindle. We'll get our coolant ready. And then I will hit go. We're going to cut our profile in. All right, so now what I'm going to do is use this knob that I created for Keith's grinding setup as my reference that I'm gonna chuck. So I'm gonna flip this stock around and then reload into our 3-jaw chuck here. We'll have to see how good we are on concentricity after flipping this thing. Right. Within 5,000ths. Yeah, it's 5,000ths. All right, so I'm gonna knock this in a little better. Now we're within 1,000ths, which is about as good as this dial indicator can do. All right, I'm gonna tighten this down and we'll double check. Oh, that moved a little bit when we tightened it. All right, that's within 1,000. Let's see if we can do any better. I think I'm just riding the noise on my cut. So we're within 0.5 with this indicator, so I think that's good. We're gonna drill a center in now. All right, so I'm gonna bring in our tailstock. And we'll knock out this live center. Just by pulling the quill all the way back, and it releases this Morris taper 2, I believe. And then we can put in our drill. There we go. Lock that in. And I already have a drill center tool. My chuck is tight, I don't know why. All right, since we already dialed this into within less than 1,000ths of concentricity on our machine stud, what I'm gonna do is basically just bring this tailstock in and drill ourselves a center hole. So we'll turn on the spindle. Oh, you know what? I need to face the back first. Yeah, I guess that is a quandary. Do you face and then drill, or do you drill and then face? I think I'll face gently, since we kind of have a crooked surface there. Oh, but this thing is going to do surface feet. So it's going to go to super high RPM. I'm going to change the spindle speed to 1,200 RPM instead of surface speed. There we go. That may be a little fast, actually. I'm going to go slower since I don't have the RPM correcting surface feed set right now, because I don't want this block to fly out at me. I'm going to gouge a little bit right there. All right, well, that's squared. Not beautiful, but it's squared. So now we can come and drill our drill center. And this is basically creating a bearing to support the back of this rod of material. So the cone part of the drill center creates that bearing surface for the live center to nestle into. So that should be enough. So we'll kick out our drill chuck. I'm going to dip this live center, which is basically just a ball bearing set with a tip and some oil over here. And we'll get our live center seated in there. The thing is we're going to run a CNC program. So this tool's got to fit in this gap. So we'll maybe a little tricky. We'll do the tracking scheme on this one. All right, I need to extend my tool out ever so slightly so that I clear the tailstock in this cross slide structure over here. So let me retighten this tool down in a tool holder. There's 3 grub screws that hold it in place. I may need to change out my insert as well. It's been cutting pretty good so far. So we're going to CNC the back profile. So we're going to CNC the 1¼ inch thread stud here, and then the tapered sections, and then the square 2-inch bearing right here, and then finish out over here real close to the chuck actually. So I'm going to check my tool clearance. So if I get 1.25, which is our thread diameter, then we should, and I don't crash here, then we're good. It's going to be really close, 1.28. I got to go further out. You don't want to stick the tool too far out because you get more chatter, but you also don't want to crash into your tailstock either, because this is going to be a CNC operation like the last one. All right, we'll put this out a little bit more. We'll test again. Oh wait, I need to reset my tool height because I changed it. All right, well now we're going to have more clearance, or plenty of clearance. I'm thinking 2.353, 2.353. So I'm going to touch off and because I moved the tool in the tool holder, so I got to reteach the tool location. Okay. So I'll measure that skim cut we just did. And since this isn't super accurate because Keith is going to heat treat and then post grind, we're not too concerned about absolute measurements here. So that's why I'm not using the micrometer per se. But I do like to wiggle the caliper to settle in the measurement. So 2.351, 2.351. All right, I'll update that on the x-axis. Absolute set. Okay, now I'll bet I can get into the 1¼ inch without crashing over here. I like to have a decent amount of clearance anyway. Oh yeah, so I got like a pencil width of clearance there. That should be enough. Okay. And now what I need to do is I need to basically find this, whoop, it's off camera. I need to find this location and then back calculate to the end of the part, because this is the edge of our part from the first operation. 5.415. So I know that this position now, Z, is 5.415. Absolute set. And you know, this is the end of a thread, so if it's not exactly right on, it's not the end of the world. All right, I've got some extra stock on here, so I'm gonna go ahead and turn down this side of the part to the finished size. I actually have like 0.3 inches of extra saw stock. So So we're gonna redo the center after I'm done hogging off this material. And I guess I'll get some coolant on here too so I don't burn up my bit. All right, so I added this magnet spacer onto the chuck, and this is the second part. I did the first part with some, I guess, refinements, and I discovered I needed this spacer to space off the part a little bit. So because I was getting a little too close to the jaws. All right, so we'll load our next blank in for our wrist pin, and I'll clean off the kind of the post here and tighten her down. And then we will check with our mag indicator. All right, oh, look at that. It went right to 0. Okay, let's spin this and see what we get. So I guess plus 0.002 minus 0.001. That's pretty good. And it says we're high on this side. So I'm going to give it a little bit of a bump here. Using my hand, I'm pulling down on the stock to prevent my impacts from causing recoils and knocking this part to some other weird location. Kind of like a dead blow action. All right, that needle's on 0. So now I'll spin. And we're within 0.001. This is a high spot. I'll see if it's worth trying to bump it in anymore. Yeah, it's about 3/4 of a thousandth. And since this is going to be rough turning, because Rucker is going to actually load this part into his grinding tool and then actually grind this into the final shape, or custom fit it to his worn Stoker Steam Engine bearing. So I think we're good on that. Recording? Okay. All right, so we're going to import the DXF file that defines the profile of our wrist pin. So I just turned this controller on. It always wants to know how fast you want to run the spindle. So I told it that. And now we're going to hit the program in and out button and open. And I've got a USB stick in the side of this controller, and our DXF file is this one right here. So I will click on open file, and it shows the profile that I created in a drawing of SolidWorks that was based on that CAD file that I showed how, I guess I showed that in the side pan of the video. But yeah, I modeled this wrist pin up in SolidWorks, and this is the profile in a DXF file. So we like that, so I'll hit continue. And it wants to clean up the gaps, if there's any gaps between lines. So we'll hit yes. Now here we can decide where the 0 location of our part is going to be. And it gives you some options. We're gonna choose the closest midpoint of a line and arc. And that'll be the tip of our part. Oh, I gotta hit C first. And then you double click on the line, and it says, okay, this is the center, or the 0 location of our part, which happens to be the center line. So hit continue to that, and we can just show the part that we're gonna turn instead of the back side of the part. So we'll hit X positive, and it'll kind of bifurcate the part. We can zoom out as well, so we can see things a little better. Okay, and now saying you can add or remove lines, so we'll just hit continue. We don't need to do any of that. So now this took a while for me to figure out, but if you hit the cycle button, that means it's gonna stitch a bunch of machining operations together to create this profile, and it's called a cycle. So it'll do the chamfer, and then the diameter for the thread mill, and then the radius, and a continuous cycle of features. So we'll click cycle, And yes, we want to chain. That means you want to select all the lines. So we'll say yes to that. And we will click our first line, which is the chamfer. We can zoom around. And then the next line we click, it will assume, okay, you want to machine this whole profile, and it made it this purple color. So now, it took me a while to realize that now you come up here and you click event. And there's a bunch of events that creates this profile. And you just answer the question. So the stock in the X direction is 2.5 inches. That's the rough stock that we're loading into the mill. And X begin we set with the mouse. And then you just go through and answer these questions. So depth of pass will say 1.1 inches. Approach will be from the Z axis, so the tool's going to come this way instead of that way. RPM will say 1200, and incremental set means RPM. ABS would be the surface feed, which is how a constant feed of the tool, which goes faster as the tool goes to the center of the part. But we'll just keep it simple with incremental set. Feed will say 2 inches per minute, which is incremental. We're going to use tool number 1. Finish cut will be 50 thousandths, and we'll say 1200 for the finish cut. Finish feed we'll say 2 as well. These are just representative numbers to show you the process. And our finish tool will be the same as our beginning tool. So now this line turned green, which is a good sign, and it also says all okay up there. So
it checks everything for you.
Yeah, and it took me a long time to get to this point, to see that little all okay. Because I don't know, the instructions weren't great, so I kind of had to self-teach. And then to get out of this event, so you can continue with machining, you have to click event again. So there we go. And then end DXF. It says, are you sure? Yeah, we're sure. So now you got to set up your tool and your a few other things. So we'll go to the setup, tool setup. We're gonna set up tool number 1. This will be a new tool and a right hand turning. And then you can move the tool to your 0 location and then set the 0. Okay. We also need to set up a reference position. That's kind of the all clear position for changing out the tool.
Like
between
a home position or something?
Yeah, like a home position or a tool change position.
Okay.
And we'll just set where it is right now because this is a demo. Okay, go back to mode. Now we go to setup one more time and then tool path, and we should see the tool path that the machine will take. So the red line is rapid and the blue line is the cut path. So it's going to hog out with these parallel lines all the metal, and then it'll do a first cleanup pass and then a final finish pass. And then I'll show you how we do that next. All right, I got the next wrist pin stock loaded into our lathe, the CNC ProtoTrack SLX. And I'm gonna run the program. So we go to mode, run, start, ready to begin, press go. Okay, so we hit go, and we move to our tool change position. Then we have to tell, you read the little instructions here. So start the spindle forward, and the spindle started. Then finally you hit the go button. And it starts. We're gonna cut some air here. Again, I'm kind of being safe. So I'll come back once we start cutting into the part. All right, now we're cutting. It's kind of tip breaking, but also creating like a little wad of Brillo there. Coolant. And up here on the controller, we can show the path. kind of like before with the first op, this is just more of the same program. Show program, this is the event we're on, cycle. This is all programmed using the DXF curve import utility. So yeah, it kind of says the beginning and end of the X for each operation. And it kind of overlays like simple shapes like radiuses and chamfers and linear cuts and things like that, and then figures out how to hog out with these blue lines and then do the final profile cut. So coming up at the end of the second roughing pass. We'll see how we go and get our next bite. Getting pretty good chip breaking there. And that's where we're at. All right, I'll get back once we're closer to the finish cut. Pretty good finish. There, chips shooting off. Alright, there we go. Still a little warm. Cool it off and we'll check it out. Okay, we're ready to do some single point threading. This is a local program that I wrote on this CNC lathe. And basically the thread cutting tip, which you're gonna see, actually you can see it here, right here. It's a single point, the profile of a standard thread. And we're gonna do 1/1000ths per pass cuts. So the first is gonna be a scratch pass, just to see the 7 threads per inch. And the CNC lathe has basically figured out how many passes to do based on the geometry of that triangle. So, but I do usually forget that I should only take 1/1000th per pass on these on steel threading, especially large steel threading. So I'm going to hover over this thing with the oil can and keep a lot of oil on it to try to keep my new carbide insert from busting off. I already did one, and I did already snap off the tip of my carbide insert. So I slowed everything down. So we're going to do 1/1000th pass, and it'll look like it's not doing much of anything at the beginning because you're at the tip of the triangle, but when you're fully deep into the thread and the whole face of the triangle is cutting, that's where you get a lot of stresses. And we're going to do 300 RPM, and basically the CNC lathe will track the thread exit exactly at the right spot every time. Oh, and one thing that I do recommend is if you're doing CNC threading, back the tool off away from your stock and then do a air cut and see that you're not actually going to crash your tool into this hard stop that we have. Even after that, I told the lathe to cut short, and I slowly inched my way forward until I was right at the radius transition of this thread. So anyway, all that being said, let's go ahead and do it. So I'm going to hit go and turn on the spindle, and then when I hit go again, it's going to start threading. I'm going to give it some oil. I may override the spindle a little bit because it still sounded like it's having some rough time. All right, there we go. I think a little bit of this tip may have broken off too. Yeah, a little bit. All right. Looks like I need to do another pass. Probably change out the tool because I heard a chunk of it break off. Yeah, it doesn't want to start. Yeah, not even beginning. All right. So I'll flip this tool over and try again. There's two cutting edges on this thread cutting insert. So yeah, you can see the whole side busted off. Maybe it's one insert per thread. I guess I could do 1/1000th pass. Maybe I'll do that. You can't really increase the RPM because then you'll just be shooting faster into your part. Okay, so I'm going to go back to the thread cutting program and go to the beginning. Program. Go to beginning. Okay. So here's the information for cutting our thread. I guess I'm going to do half a thousandths. So data forward, we'll say 0.0005 thousandths. I still got 300 RPM, but maybe I'll lower that to 225. Okay. And then we'll run this again with our new insert. You can probably see how rough those threads cut in. That's even after I kind of cleaned them up a bit. All right, mode, run, start, go. We'll get the live center back in there. And since I didn't really move this tool or everything, the lathe should have remembered the helix start and all of that. There's an angular encoder on the spindle. Okay, so I'm going to hit go, but we'll find out here. Yep, looks like it's good. So now we're doing half thousandths increments. So we're going to be waiting a while. I'll get some oil on here anyway. And thanks for watching Dragonfly Engineering, and I'll see you guys next week. All right, bye.